Hello and welcome to Dr. Mode's chemistry class. This video is going to be about gas law stoichiometry, and specifically we're going to look at the volume-volume equations. Okay, we need a reaction to consider, and this is a good one because in this reaction both reactants and both products are gases. This is the combustion of methane, which is the major component in natural gas. So we need to balance this chemical equation, and when we do that, we discover that there is a 2 that needs to be in front of both the oxygen gas and the water vapor. So we got to remember what this means. When we read this, what we should be familiar with is that what this says is 1 mole, or for every 1 mole of methane, it requires 2 moles of oxygen gas to fully react, and it produces 1 mole of carbon dioxide gas and 2 moles of water vapor. Well, in these types of problems, there is a different way of looking at it. Not only are the moles proportional like this, but we can look at a portion of volume, assuming that these are ideal gases. So what that means is we could read it like this. For a particular amount of volume of methane, it requires twice that amount of oxygen gas to produce the original amount of carbon dioxide and twice that amount of water vapor. So here's a question that you might get about this reaction. So let's say if 74 liters of natural gas, CH4, reacts with 122 liters of oxygen gas at standard temperature and pressure, then what is the limiting reagent? What is an excess? How much excess is there? How many liters of CO2 and water vapor are produced in this reaction? So we got to start with our balanced chemical equation. And the problem tells us that we have 74 liters of natural gas, so we'll write that underneath the methane, the CH4. It tells us that we have 122 liters of oxygen gas, so we'll put that underneath the oxygen. And then it asks us how many liters of carbon dioxide and how many liters of water vapor will be produced in this reaction. This is the information that we have so far, and what we need to do is we need to determine what the limiting reagent is using these numbers and the coefficients of the balanced chemical equation. So what we can do is we can start with the 74 liters, and we could say if we were to fully react that 74 liters of methane gas, how many liters of oxygen would it require? And if we use the coefficients, we can determine that it's going to be twice as much, 148 liters. But we can see we don't have that much. We only have 122 liters. If we do it the other way, we can see if we have 122 liters of oxygen, how much methane gas is it going to require? Well, we can multiply by the ratio of the coefficients, and that tells us that it requires 61 liters, and we have more than enough there. So what that tells us is that oxygen is the limiting reagent and the methane is in excess. So we know that the CH4 is in excess, but we need to determine how much excess there is. So we can use our calculation from the previous page where we took 122 liters of oxygen that we know we're going to fully react, and we determined that that requires 61 liters of methane. So to determine how much excess, what we have to do is subtract those two values. The next thing to do is to figure out how much carbon dioxide and water is produced in the reaction, and we want to determine both of those values in liters. Well, we can use the coefficients again and start with the 122 liters and For determining the CO2, it's a 2-to-1 ratio, so 2 parts of oxygen for every 1 part of carbon dioxide. So we just multiply by that, and we end up with 61 liters of carbon dioxide produced. And then for water, it's a 2-to-2 ratio between the oxygen and the water. So we multiply that to figure out that there's 122 liters of water produced in the reaction. So here are all the questions that were asked. So what are the answers? What is the limiting reagent? Well, it's the oxygen gas. What is in excess? That would be the methane gas. How much excess is there? Well, we found that there are 13 liters in excess of the methane. How many liters of CO2 and water vapor are produced in this reaction? Well, there are 61 liters of CO2 and 122 liters of water vapor. We hope that you're finding these videos useful and we could use your support, so please like, subscribe, and share the video. Thank you very much.